Okay, so let's begin learning about functions. Well, to start, we need to understand what a function actually is. So what is a function in math? Well, a function is defined as the following. So a function from A to B is a subset of A crossed with B, where this is going to be a Cartesian product, so that every element in A, we'll just call that x, every x in A has exactly one element in B, which we'll just call that some general element in by. So x, the ordered pair xy, is in F. Now, some important notes I've already made. When we say A cross B, in this case, we're talking about the Cartesian product. The second super important point is we're saying every element in A has exactly one element in B that it matches with. So what do I mean by this? Let's go back to our definition of a Cartesian product. Okay, so let's go to this visualization, because that's going to be a lot easier for you to be able to see. So when we're visualizing what a function is, let's take our Cartesian product. And we know that a Cartesian product, let's say we have just some discrete elements, right? We have 4 elements in A and 3 in B. And we say the Cartesian product is going to be all of these points down here. So when we say every element in A has only one element in B that it can be paired with, what we're saying is this element, let's just call this the number 1, 2, 3, and 4, and let's call this A, B, and C. Let's just write this out a little bit nicer. Okay, we're saying 1 cannot be paired with A, B, and C at the same time. It can only be one of these 3. So let's let 1 be just paired with A. It cannot be paired with anything else. So what this means is we're going to erase these other 2 crosses. Similarly for 2, let's pair 2 up with B. So let's erase these 2. Let's pair 3 up with C, and then let's pair 4 up again with A. So there we go. This is what a function actually is in terms of a Cartesian product. Remember, the Cartesian product is a set of all ordered pairs, but in this case, it is a function, and a function is going to be a subset of the Cartesian product. So it's going to be a select few of the ordered pairs from all of the ordered pairs in the Cartesian product. So in this case, the select few were these 4, and they have to meet this bottom criteria down here. And another way of thinking about this is, remember when I said a Cartesian product is really like a graph? You're creating like an x and a y axis almost. Well, in this case, that's exactly what we've done. We've created an x and a y axis, and we're saying, well, if you were to, like, let's say, imagine drawing a line, right? The line cannot be both up here and down here at the same time, is what we're saying the definition of a function is. Now, in high school, you might have been taught that there's something called a vertical line test for a function. That's where this comes from. You say that when you have, let's say, 2 points here, and you draw a vertical line on this blue line, you're never going to have the line cross this vertical line I'm going to draw twice. So for example, if this was our function, no matter where you draw a vertical line, at no point is this vertical line going to cross the blue line more than once. However, if we had in our function the pair 2b and the pair 2c in our function, so instead of having every a has 1, it has, let's say, 2, our vertical line test wouldn't work, because you would see that if you draw a vertical line exactly at 2, it crosses 2 points along our function here, because you would have something like this, right? You just have like a blue line sticking out. I don't even know how you'd represent this. But that's really what this means. That's where this vertical line test actually comes from. It comes from the definition of what a function means. It means that every element in A can only have one pair in B. But, very, very important to note, B can be paired with multiple things in A. So as you notice here, A can be paired with 4 and 1. It doesn't have to stay exclusively with 1. So you can think of this like a relationship, right? Everything in A can only have a relationship with one person, right? A can only be in a relationship with A. It cannot be in a relationship with A, B, and C. However, B doesn't have those rules. Anyone in B can have multiple relationships. So as you notice, B, the letter A has 2 relationships. It has a relationship with 1 and the relationship with 4. So that's another very important note to take here. Another way of thinking about this is to draw out the sets A and B. So when we take something like this, and this would be our set B, and this would be our set A, and we say the function, which is going to be f, goes from A to B, what we're saying is, if you take an element in A, right, let's take these 4 elements, and you have some elements in B, a function is kind of like the arrow. That's kind of what a Cartesian product is. It's an arrow, but a function specifically means that from A, you can only have one arrow coming out of each of these dots, each of these elements. So you can have something like this, and this would be a function because every element here only has one arrow. If we, for example, had something like this, and then that would not be a function because this element here, let's say these are the numbers 1, 2, 3, and 4. We notice 3 has 2 elements in B, but our definition says that it can only have 1. So this is not a function. What else do we know? If you drew something like this, where you don't break this rule, but what you end up breaking is this other rule that we have to have, every x in A. So this is also not a function because even though the elements have no more than one arrow, one of the elements in A does not have a pair B, which is not correct for our definition of a function. We're saying everything in A has to have an arrow. So in this case, this is also not a function.